Now that we've defined it, we want to look into using molar mass. We know that 1 mole is always defined as the same number of objects. Doesn't matter what you are counting. If you have a mole, the size of the group of objects is always the same. But the mass of that mole depends on the substance. And that is described by the molar mass. And if we think about molar mass, it is the grams of 1 mole. The units are a compound unit. That fact that it's a compound unit, grams per mole, is going to be an indication that it's going to allow us to convert between the mole representation and a mass representation. And so, depending on what you're looking at, something like water molecules are quite small. And so 18 grams, each 18 grams that you have is water. Okay, and so if you have, say, more than 18 grams, for every 18 that's in there, that is 1 mole of water. Something like, say, iodine molecules, those are big atoms. You got 2 of them in a molecule. It's quite a larger mass for a mole. And so it takes up more space because those molecules are bigger. But again, if you have 1 mole, it's 253.8. For every 253.8 grams, you have 1 mole. So this is a conversion factor that's going to let us go back and forth between grams and moles. Let's use it. What is the mass of 1.7 moles of PbO? What do we want? I want mass of PbO. What is the mass? We can see there's no number associated with it. That is the units we're after, so grams, kilograms, something like that. What do we have? What numbers are we given associated with units? Moles of PbO, lead 2 oxide. So we have moles, and we want to convert into mass. You will note that when we look at these kind of things, when we look at this is a new conversion factor. If we look at compare, we can see that PbO is the same in both cases. So we're not changing our substance. We're not changing what it is. We don't use molecular formula, anything like that. What is different is how we're dealing with that amount of stuff, right? In this case, we have a counting unit of moles. In this case, I want mass. That is not a counting representation. So we want both of those descriptions, mass and moles. We want to go back and forth between those for our PbO sample. Okay. When we want to relate that idea, changing how we are looking at this amount. We're not changing how we're counting it. We're not going to use Avogadro's number. We're changing entirely how we're looking at this amount of stuff into mass. And if we want to do that conversion, we need the molar mass of lead 2 oxide. Okay? And in order to get the molar mass of lead 2 oxide, we need to use the periodic table. So let's actually compute it out, see how it goes. All right. What is the mass of 1.7 moles PbO? I got my moles of PbO, and I want to know the mass of it. Okay, so I've got So I know I'm wanting to go from moles of PbO to grams of PbO. So whenever I see this type of conversion going between grams and moles, that is where I need to use molar mass. Molar mass is my conversion factor between grams and moles. So molar mass is not something I can look up. It's not Avogadro's number. It's not any of those values. It's not. I can't use the molecular formula right here. I need to use my periodic table. We've looked at computing formula mass. Computing molar mass is the same idea. We use those values. So we look for lead, P. We look for oxygen, O, and pull those values off of the table. So let's compute our molar mass. We know based on the formula that it is 1 times PV plus 1 times O. 1 of each atom in this compound. If I look up PB on the periodic table, I can see it's 207.2. This is actually lead doesn't only has one digit after the decimal point for its sig figs. So we want to maintain that, 207.2. And the units on there, because I'm calculating a molar mass, is grams per mole. It's the exact same number that we would have pulled off for the formula mass, but we just have to know that it's grams per mole now instead of atomic mass units. Oxygen, 15.99. I'm going to round to 16.00 grams per mole. That's one we'll use a lot. That's one you may just end up memorizing just from brute force of doing chemistry. So when we combine these, we want to keep that one digit when you're after the decimal point. That's your sig figs. For rounding here, 223.2 grams per mole. So I've computed my molar mass now, 223.2. And I want to go ahead and use that here for my conversion here. So one of the things you'll note, this 223.2 grams per mole. I only have one number explicitly given. But if we remember, I have this compound unit, and per mole means per 1 mole. So I can take this and I can write out the equation or the equivalence that 223.2 grams of PbO is equal to 1 mole of PbO. Okay, so when we compute the molar mass like this, there's always an implied 1 next to it. So conversely, when we're using molar mass to do conversions, it's always going to be 1 on the mole, and then the number you compute always stays next to gram. Gram can be on the top or the bottom, but the molar mass that you actually compute is the mass. It always stays next to gram. So we can see that moles cancels out moles. We do our multiplication with 7 times 223.2 divided by 1. One of the things you want to note, sig figs can get a little tricky here. This is actually only 2 sig figs, right? That's 2 digits. There are 4 sig figs in this bad boy. 2 is definitely going to win. 380 grams of PbO, which is lead 2 oxide. So the molar mass lets us do this conversion. 1.7 moles, that's a representation of an amount of PbO that's based around number of atoms, ions, formula units in that compound. How many objects are in there? This mass representation is how much just stuff is in there. Those lead atoms are very large, so the mass is quite big, right? Over almost 400 grams for 1.7 moles. But 1.7 moles of water would be the same number of molecules, but it would have a different mass because it has a different molar mass. Okay, so lead's pretty big. So lead's a very big atom, right? It's 207 for the atom. So that's why the molar mass is so high and why there's a lot of mass for that number of things. But 1.7 moles is a count of the number of atoms, in this case ions, present in your sample. All right, so we've seen, we've built up this language of how we can talk about quantities of things. We started with, the idea that we're going to deal with a certain number of atoms. We're going to be dealing with a lot of them, so we're going to use moles to count them. But we need a practical way to measure them, and mass is what we need. So we have to be able to convert those moles into mass, and molar mass is the conversion factor that lets us do it. This is a unique value that we can come up with on our own for any given substance based on the information that's on the periodic table. We can use it to our advantage. We have talked about 3 different types of conversion factors here. We started with molecular formula. That was something we've talked about previously, but now we're using it in a new way. Molecular formula is unique for a given compound, and what it lets us do is convert between atoms and molecules. This is the only type of conversion factor we've talked about today that lets us go between different types of things, atoms and molecules. Those are you would have 2 different formulas that you'd be writing out, and we'd want to be able to use those. Avogadro's number then lets us change how we count something, right? Once you've picked what object you're looking at, is it an atom? Is it an ion? Is it a molecule? Then you're talking about, are you counting in groups, as in whole moles, one at a time, or are you counting individual objects, molecules or atoms, giving you a total count of everything you have? Avogadro's number is our conversion factor. It is always the same. It does not matter what you're looking at. We always define the mole to be the same. Our final conversion factor is our friend molar mass. This is something we're going to use a lot, again and again. This lets us convert between mass, which is a grams measurement, and moles, which is a counting measurement by group, right? And molar mass is unique for a compound. Oftentimes it's not given to you. Sometimes it's given to you. I will give it to you sometimes, but other times you have to figure it out on your own. And you can always calculate the molar mass from using the periodic table, looking up those values on the periodic table and adding them together.